So calculus 30, 7.4, number 3. We'll just do this question here. So it says this triangle ABC is inscribed in a semicircle with diameter BC. So here's my little diagram I started. A semicircle is half a circle, and so that means that this line BC is the diameter of the circle going right through the center. And BC is 10. Now when you have a triangle inscribed in a semicircle, this is always 90 degrees. Okay? So I don't know if you remember, the reason why that is I think you might have looked at this back in grade 9 or something. But if you have an angle like this, and we have an angle formed with the center as well, so this angle x is always twice this one. So this is always half of this central angle here. And so if this is an angle of 180 degrees, this is 90. Okay, you remember that? Don't know if you remember that or not, but that is the case. That's why this is 90. If this is a diameter, that's 180. This is always 90. Okay? All right, so it says find the value of angle B right here that produces the triangle of maximum area. So it's a bit of an optimization problem, I guess, here, right? So maximum area. Okay. So what are we going to do here? Well, let's see. Area of the triangle is going to be 1/2 base times height, I guess. Right? Okay, so maximum area, okay, of the triangle. Now, what's the base and what's the height? Doesn't really matter. One of these is the base, one of these legs, if it's 90, and one of these is the height. Right? Because it's a 90-degree triangle. So it doesn't really matter. But if we're going to maximize area, we need to take the derivative of area. But an issue that we have is that we want to write this in terms of just one variable. And of course, the variable that we're looking for here is angle B. So I want to write B and H in terms of theta, or in terms of B, big B. So, how did you guys do that? Because you guys did this one, right? No? Yeah? So do you guys have this started or done as part of your assignment? Yeah, no? No? Okay. All right. That's why you wanted me to go over it, eh? Oh, okay. Because you haven't done it yet. Oh. Yeah, you can go over that one. Sure, it's nice. Double check some things. Like everything. Double check everything. Single check everything, actually. I just want to single check it. Just for the first time.
Yeah. Can you decide also because you know the angles?
Yeah. Okay. Yes, exactly. Okay. This is chapter 7. So we're doing derivatives of trig functions, right? So can we write angle B in terms of, trig functions? Of course we can. So this is actually the opposite side, right? See that? Opposite. That's OPP, in case you didn't know. And so this is hypotenuse, which is 10. So opposite and hypotenuse, what trig function is that? Sine of B equals H over 10. Or H equals 10 sine B. Okay? Now what about B? Okay, so how do we write B here? Well, this is adjacent and hypotenuse. So adjacent hypotenuse, that's cos, right? Cos of B is little b over 10. Is this making sense? Okay. So here now I have H and I have B. And so it's going to be area is going to be actually in terms of big angle B, right? So it's going to be 1/2 10 cos B times 10 cos, sine B. Sorry, I got another room there. Okay, we could further just simplify that. So this is 100 times 1/2 is 50 cos B sine B. Right? Okay, so that's the start. Now, since most of you have not even started this question yet, I'm going to get you to do the rest. I'm going to give you a few minutes to work through this. Just like a maximization problem, right? Except with trig here now. Take the derivative, let it equal 0. Find out what your critical numbers are. And give me the value of angle B. Okay, so take a minute to work on that. Okay, so your solution should look something like this. And what you also need to know, or you need to realize, is that because we're dealing with a triangle here and an angle, the domain for B needs to be between 0 and pi over 2, or 90 degrees, right? So that's why you only have just this one answer. You're just talking about 0, pi over 2. Where does sine and cos equal each other? Well, on the unit circle, you see that this point here, which is the angle pi over 4, or 45 degrees. Okay? And it's your only critical number, so if you do sine analysis, you guys you'd be able to see that that's going to be a maximum. But if you also just use your common sense, I suppose, right? Because if we have a semicircle like this and you have this tiny little triangle like that with a really small angle, is this going to be a larger area or a smaller area than one if it's 45, right? Quite a bit smaller, so then you understand, hey, this is probably a maximum, because any of the other triangles I can think of would have an area that's smaller. So, does that make sense? Is it making any sense? Migration instinct? Any of this? Ringing a bell? Yeah, it's from an old movie. Ice Age, remember Ice Age?
Oh,
You know Sid the Sloth?
That's not that
That's
old.
not.
That's pretty old.
It's not
We were a
that.
lot. That was like our time.
Sid is a lot.
That was your time. Okay, well, whatever. My kids like that one. Okay, back to calculus. You got that answer or no? Madly trying to copy this down?
No one read us.
Yeah.